Hi there, folks. Welcome to our final lesson from Science 8. It's going to be all about oceans. We're going to be examining something that wasn't really fully touched upon in our PowerPoint. It is in your textbook, so I would definitely check it out. There are some questions about this in the review Kahoot. What am I speaking about? I'm, of course, speaking about the ocean landforms. Things such as seamounts and oceanic ridges and trenches. So we'll be discussing that in some great detail. We'll also be going over some ocean-related concepts that are in the PowerPoints, such as the different levels of the ocean and what kind of creatures live there. And we'll be discussing a little bit more about the direct and indirect human uses of water. I'll also have some parting sentiments at the end. So if you're just here for the emotional part, well, skip on ahead to near the end of this video. Okay, so this is a little bit more complex. And so this is why I wanted to focus on these different ocean features so that you'd feel comfortable about this. So our first feature we're discussing is the oceanic trench. So the oceanic trench, as you can imagine, is like a trench. A trench is like a big ditch. If you're a big history buff, you would know that in the First World War, both sides would dig in. They dig these big trenches and use them as protective fortifications. So imagine a big ditch in the ocean. So the ocean floor dips. So the question is, how is that formed? Well, actually what happens is you get these tectonic plates or plate tectonics. And these are the big pieces of land that are moving around underneath the ground there. And you looked at that in grade 7. And so an oceanic trench is formed when one of these plates slides underneath the other. And so what will happen is you'll kind of get a gap. You'll get a gap between them. So imagine, even for example, let's look at these two notepads. So we've got these two notepads. And so imagine one is sliding under the other, and then you've got like a ditch here. You've got your trench, and actually the Marianas Trench is an oceanic trench. It's actually the deepest point on the crust or the surface of the Earth, if you're including both ocean and land as part of the Earth's surface. And it was actually in the 1970s, I believe, when there was an explorer who took I think it was the bathysphere, and he which was like a small submarine that was like really tough and could withstand those intense pressures, and actually went all the way down to that deepest point. I don't want to say the deepest point on the planet, because that would technically be right inside the core, but the deepest part on the surface of the Earth. So that is an oceanic trench. We also have an oceanic ridge. So oceanic ridges would appear as underwater mountains. So that is oceanic ridge, just like the ridge of, your hair, the ridge of the desk. Take a look at the ridge of this desk. You can also check out my new mouse pad. I got a new mouse pad, and it has got an animal on it. It's not an animal you'd find in the ocean, but it is. That's right, it's a bunny. Okay. So, anyway, so that was the ridge of the desk that you saw as well. Hopefully you saw the ridge of the desk in addition to the adorable floppy-eared bunny. So the oceanic ridge. So how does an oceanic ridge form? The oceanic ridge, actually what happens, this is really cool. So it forms when, instead of converging, instead of coming together like with the trenches, the oceanic ridge is when these tectonic plates, or plate tectonics, when they diverge, when they move apart. And the question is, okay, well, what's underneath? Well, underneath, because this is the Earth's crust, that the tectonic plates are part of the crust, underneath you have the Earth's mantle. And you may remember from grade 7 that the mantle is made of, it becomes a lot more fluid, so it's molten magma. And so as this magma is now exposed, it comes up, forms as lava, and the lava immediately, let me write this here, it says lava. In real life, when you see lava, it doesn't have the letters lava on it. That's just in this diagram. So the lava comes up. Now the ocean water is cold, especially down there. So when this lava is then exposed to this water, it will very, very quickly cool and form, basically because it came up in big heaps and lumps. It will form then, that hardened, cooled lava will become a mountain range, the ocean ridge. So pretty exciting right there. And so when we look at, okay, why are these tectonic plates even moving in the first place? Why don't they stay put? I mean, this is ridiculous. Like, do they need a babysitter or something? Geez, tectonic plates. Well, the reason why is because we have layers underneath the Earth. It's not just considered the mantle. We actually divide the mantle further into different segments. So right underneath the crust of the Earth, and actually including, this particular area includes like the lower part of the crust and the upper mantle. It's called the lithosphere. Okay. The lithosphere. Yes. And underneath that, further down into the mantle, we have what's called the asthenosphere. Okay, so bear with me here. So we're going to say that this is, I'll hold this up a bit more, that this is, we're going to do a pretty little crust of the Earth, happy little crust of the Earth, and then we've got the rest of this lithosphere. And so I'm just going to do lith for short. And then we've got the asthenosphere. A happy little asthenosphere. All I need is an afro and then or a nice permed haircut, and then I can host my own public television show with this. Okay, so what matters here, where it gets really volatile, where we get this movement, is when we have this meeting. This border of the lithosphere and the asthenosphere. Oh, I wrote the whole thing out down there. And so that is called the lab, the lithosphere-asthenosphere boundary. And so this boundary, scientists have estimates of this, right? Because we have, seismologists in geology. We can study earthquakes, volcanoes. We can often predict when this seismic activity will occur. But no one has ever dug hundreds of kilometers down into the Earth. So no one has actually ever been to this lithosphere-asthenosphere boundary. But there are estimates, most scientists estimate that depending on where you are in the Earth, that this boundary, where you get the mix of the more molten asthenosphere and the more solid lithosphere, that this boundary is somewhere a few hundred kilometers deep below the surface of either the Earth on land or the ocean floor. The one exception, though, happens when you have the oceanic ridges forming, because this is direct exposure here where this boundary is coming right up. You're getting the molten lava coming to the surface. So in that case, the lab, it's not just a flat line. It is happening right there, having exposure to the water, which is pretty cool. Okay, well, it was hot, but then it gets cooled, right? Okay, so there are two more features. So those are the trenches and the ridges, but there are some that are a little bit more individual, and they are the seamounts and the volcanic islands. So we'll talk about seamounts first. Seamounts are basically just volcanoes that are underwater, right? Makes sense, pretty easy. So I'm going to draw a happy little volcano here underneath the happy little water. Okay, so when seamounts, though, when they erupt, so let me write that out as well, seamount. So it's just the word sea, like under the sea, and mount. It kind of makes me think of a seahorse, because you mount a horse, right? It'd be kind of fun to ride a seahorse. The other people might stop and stare, but hey, who cares, right? You be unique. You do what makes you happy. So now sometimes, though, as you know, volcanoes can erupt. And so when it erupts, it's actually very similar to the effect that's happening when oceanic trenches are formed. So you get this lava that is spewing up, and it's immediately cooling. And so as it cools, it hardens and forms a volcanic island. Beautiful. So volcanic island, the definition of a volcanic island is not an island that has a volcano on top, although I guess in a sense that would be a volcanic island because it's got a volcano. But when we talk about features of the ocean, a volcanic island is formed by, like, it exists in the first place because of the volcano. It's not necessarily that it has a volcano on top of it. And as you can imagine, yeah, there's still a volcano underneath that still has potential for further seismic activity. So you want to be careful with that. The thing is, this lava, it often produces a lot of rich minerals, and this can often make it very rich for life. So these volcanic eruptions, of course, they destroy and decimate everything there, but many, many years down the line, they can provide very rich, fertile conditions. You even look at some of these tropical areas that have rainforests. It was often, the volcanic ash that formed the original basis of that. Okay, so those are our 4 features. Oceanic trenches that were formed by the tectonic plates, one coming underneath the other. We have the oceanic ridges, so when we open up, and then the lava comes up and forms a mountain. We have our seamounts, these underwater volcanoes. And then we have our volcanic islands, which are formed from the hardened lava that comes from the seamounts. Okay, so now those are our features, but what about the creatures that live underneath the sea and around the sea? Okay, so there are 4 areas we're going to examine. Our first one is the estuary. So an estuary is the fan-like ending when a river empties out into either a lake or an ocean or a sea, any kind of large body of water. And so because you have the freshwater rivers emptying out into what is often a salty body of water, you get what's called brackish water. And that's where the salt and the freshwater mix. And this actually allows for a great amount of biodiversity of both plants and animals. So you can think of like swamplands and marshes as being some kind of areas where this could be. And so it's easy to confuse an estuary with a delta, partly because you often see them in the same area. So the definition of an estuary is this fan-like opening out of the river into a big lake or an ocean. Now with a delta, the delta is very distinct. The way you see it, it's got little fork-like shapes. So the river carries, as we examined, if you watched the Winnie the Pooh lesson, the river is carrying sediment. And the sediment then will often deposit and form lumps at the end of the river. And so then the water has to kind of work its way around that, and it looks like it is kind of a fork-like shape with many, many little fingers, or tines, if you will. So the delta will look like this. And so often with an estuary, if that mouth of the river was carrying a lot of sediment, then you will get a delta in your estuary. So you can see this even if you go to Google Maps. One very famous estuary with the delta is the Mississippi River Delta. So if you go down to Louisiana, look at the Gulf of Mexico, you'll see this river, and it empties out, and it's quite lovely, quite astounding to see. Now, as you can imagine with erosion, actually they talk about how places like New Orleans are getting to be underwater because eventually the soil is eroding away from the continued water that's coming there. So so very rich in life, but pretty much whenever you're very, very close to a river like that, that's a powerful force of water over a long time. So maybe don't live right next to the river, but it's a source of livelihood. Okay, so all kinds of things live there. So often if you've ever been to a swamp, I have one close to my house, all kinds of creatures there like ducks, all sorts of birds. Birds will often migrate there because there are all sorts of plants, like the red-winged blackbirds love to sit in the trees, sit in the cattails, those things that look like hot dogs. It's great. And so very diverse. And we talk about Alberta is very passionate about saving our wetlands. I know you've probably looked at this in earlier grades and talked about all these different species that call the wetlands their home. I like to call it a swamp. But so very sensitive areas, and those creatures all throughout the food chain are vital in sustaining life. So we want to take care of that. Okay, so we talked about estuaries. Our next up, we're going to be going to the beach. And so we're going to be looking first off at the intertidal zone. And so as the name suggests, the intertidal zone is where the tides come in. And the reason it's called intertidal zone is because it's between the high tide and the low tide. So on the beach, if you can imagine being on the beach, maybe you've even been there, you often find creatures like starfish, or you find seashells, so things like clams. And so these creatures are very hardy. They have to be tough because they are not only getting washed and moved by the tides, but they're also being battered by the waves from the ocean. So they have to be really resilient in that sense. And things like, some plants as well that are in that area. You don't want to just be washed away. So those are the adaptations they have. You'll see the intertidal zone right there. It's beautiful. So next up, as you start to get deeper into the water, and we're basically talking anywhere from like in the water itself, past the point of low tide, to many, like dozens and dozens of kilometers out into the water, like out of sight of land even, we have what's called the continental shelf. So with the continental shelf, it is definitely deeper. Of course, you're getting underwater, but it's not as deep as the deepest ocean. Because of that, there is still plentiful access. Let me draw some pretty little waves here. There is plentiful access to sunshine and sunlight. And therefore, all kinds of plants are able to grow. And because plants can grow, creatures that eat the plants can go there. It's like kelp, I need somebody, kelp. Okay, the Beatles. And so you get all kinds of creatures. So when we talk about some of the most biodiverse areas in the world are coral reefs, these tropical reefs, the most famous of which is the Great Barrier Reef off the coast of Australia. I visited there when I was about 3 years old, and I had the measles though. I was coming down with the measles. My family didn't know though, so I was out in the hot sun, and I don't remember it, but apparently I was quite miserable. So we wanted to see it though. It's a tourist location because of all the biodiversity, which begs a very interesting question. Places like the Amazon rainforest or Antarctica, people often want to see these. They're amazing places, but should we be allowing people to go there? Is the education value worth the potential impact that we may have by visiting? Okay, and so that's a continental shelf. In addition there, you're also going to see some creatures. You'll also see some big fish. You'll see things like sharks, other creatures that aren't fish like whales and dolphins. Those dolphins, they smile so much. It's almost a little bit alarming, right? They could be like game show hosts. Okay, so I'm going to draw a little fish here. And, oh no, I made it a dead fish. Okay, well, it was swimming. Okay, so our next and final zone is the deep ocean. So in the deep ocean, especially when we get very deep, these places like the extreme depths are the trenches, the ocean trenches. But of course, you don't even have to get that deep. Just the further down you go, the less exposure there will be to sunlight. And so you get very, very little plant life. You will see then photophores. These are examples of animals. We talked about these in our light and optics unit that actually produce their own bioluminescent light. And so this was really remarkable because these were the only lights that are 100% efficient. Even our most modern light bulbs aren't 100% efficient. They produce some excess heat, but these animals that generate their own light, they are 100% efficient. So it's not like you're going to burn your hand if you touch one. Okay, so in the deep ocean though, some of these fish that you'll see, and these large creatures like sharks and whales, they are also traveling between the continental shelf and the deep ocean. So I'll draw a giant blue whale here. Oh yeah, there we go. And it's smiling. It's smiling. It has a secret it knows. Okay, take a look at this whale. We studied whales in grade 2, so I like to consider myself something of an expert. Okay, I guess that was well done. So those creatures go back and forth. Now in the continental shelf, it's very rich as well in small food like plankton, which is, oh, there we go. We got another lovely SpongeBob character. So I'm going to draw him right there. And so because of that, you get all kinds of creatures, all kinds of smaller fish that are able to eat them. The larger fish then eat the smaller ones. And so particularly as these different sea creatures are migrating through the deep ocean, there's your opportunity for the large predators like the sharks and the whales and the dolphins to devour them. And so you can think of sharks. You can think of sharks out in the deep ocean. For example, in World War II, when the American and other Allied pilots were getting shot down by the Japanese and shooting them down in turn, you'd hear these stories of like these American pilots, and they would have their life preservers. So they'd parachute out, inflate their life raft, and then they would be traveling on the sea for weeks and months. And they would hope that the Japanese wouldn't find them because then they'd be tortured in these prisoner of war camps. But in the meantime, they had sharks that were swimming around them in the Pacific Ocean, and they would be whacking them on the head with a paddle to try to keep them away. So that's out in the the ocean. So the further away from land you get, the deeper it is. And so, but also, we've heard stories about people on the beach getting attacked by these sharks. So the sharks are anywhere from the open, deep ocean to the continental shelf. You're usually not going to see sharks actually getting into the intertidal zone because then they have a greater risk of being beached. Same as whales, but of course accidents happen, right? It's always tough. Sometimes you run into a lone shark on land or a pool shark. And so, yeah, it definitely does happen that they do sometimes get on land. Okay, so those are our 4 levels. We have the estuary, the intertidal zone, the continental shelf getting lower, and the deep ocean getting even lower. Please bear in mind that even though this diagram makes it look like it's just a few steps out, that this is actually can even be somewhere in the area of like around 100 kilometers out from the shore, which is considered to be the continental shelf. So it's a gradual decline for sure. Okay, and that's why you often on a map you will see the ocean color differently, so depending on how deep it is. This is actually a big source of international dispute because when we talk about fishing rights, the countries have international treaties. Is it how many kilometers out? Or some countries say we want exclusive fishing rights on the continental shelf. And so where the continental shelf extends can be a great source of debate for that. So a lot of real human interest in where is the continental shelf. Okay, so that concludes our look at the different sea creatures, aquatic creatures, and their environments. Just to offer a little more explanation about the human uses of water. We talked about direct and indirect uses. So the basic difference, and there are some questions about this in the review Kahoot and on your actual quiz, the key difference is that direct is basically your personal household use. And that can range from anywhere from drinking water directly to using it for bathing to washing your car. Anything like that. Industrial use is considered indirect because it's not necessarily essential for life. So something like using water to develop photographs would be indirect. Having an industrial car wash, like if you had a car wash as your business, that even though just washing it yourself at home is considered direct because it's just very personal, if you're doing it on a large scale for an industry, for a business, that would be considered indirect. So basically the difference between direct and indirect is the scale. When we look at the different uses, we talk about industry. So if we're using water for manufacturing, for example, so all kinds of pumps, that would be industrial. Household use is a relatively small percent worldwide of the water that's used. The single largest user of water is the agriculture industry, so farming. So that's actually, at the time that the textbook was produced anyway, 73% of the world's human water use was through agriculture. And so when we look at even irrigation in southern Alberta, some of these very dry areas, Captain John Palliser, who explored, he was sent to check out this whole area, southern Alberta, to see, and Saskatchewan, to see if it was fit for life. And he said this is basically a desert. They called it the Palliser Triangle, basically from like Medicine Hat to Regina, And he said, no, it's not fit for farming. But thanks to modern irrigation, we're able to farm. That has an incredible amount of water that it requires, though. So that's a little bit of a look at the human use of water. Okay, so I hope you've enjoyed the ocean. It's fantastic. It's nice to kind of get your feet wet in that topic a little bit. Just to conclude, because this is our last lesson that we have together in either science or math, I wanted to thank you. Because if you've made it this far and you're still watching these videos, it means that you are just that invested in your education. And I know we all have challenges that we have to do, looking after our loved ones, dealing with many people using the same computer or the same resources. And real kudos to you. So many of you have been still doing these projects, still doing these tests, checking out the lessons, and I think that's really going to pay off because now you can say you have completed Science 8. Well, of course, once you've done the project and once you've done the quiz. So let's not get ahead of ourselves here. I wanted to thank you for a very enjoyable year, my first year at St. Gabriel the Archangel, and for a few of you, yours as well. But I felt very welcomed right from the onset. Some of my most treasured memories include at Christmas time when we were asked to pitch in to give donations of some clothes and to write a card for an elderly gentleman. And I just remember reading through some of your comments for this fellow, and they were just brimming with kindness. All kinds of messages about, thanking this guy for helping to build our society, wishing him a Merry Christmas, some funny messages as well, but that were in good taste. I really appreciated that, as well as your enthusiasm for TA sports. That was always great. The wonderful questions that you asked me in science class that often forced me to do additional research, but that was really fascinating. I also really enjoyed at Christmas time when you guys put together the potluck, and it was you who took the initiative and the leadership to put that together, which I really, really love because I really hate organizing parties. I really don't like doing that. So I like eating the food there, but I don't like putting it together. So thank you very much for that. And so I wish you all the best of luck in this last month of school, and I hope you have a wonderful summer and that it'll hopefully be very memorable and that you stay safe. And I'm very excited for September. I'm hoping we can get to as normal as we can so we can see each other again and continue on in having the joy of learning and discovering new things. And of course, the best part of junior high, behaving in a bizarre and yet entertaining fashion. So all the best to you. Take care and good luck.